Welcome back to our series on probability theory. I'm Mark Ledbetter. This is lecture video 44, part D, and we are discussing bivariate transformations. This is part 4 of that discussion. So in the previous videos so far in this section, we have introduced the bivariate transformation theorem for one-to-one functions. We've done some examples. We've also introduced the Cauchy distribution, which was the result of one of those examples. And we introduced in the last video the beta distribution. Remember that the beta distribution f of x is equal to gamma alpha plus beta over gamma beta, x to the alpha minus 1, 1 minus x to the beta minus 1. And x is between 0 and 1. And I guess we should make these pure inequalities. And then alpha and beta are both positive. They're both positive parameters. Okay? And then we said that the beta function is equal to gamma alpha times gamma beta. That's supposed to be gamma. Over gamma alpha plus beta. So it's 1 over this quantity, or the reciprocal of this quantity. Okay, so in this video we are going to discuss more examples of this inverse transformation theorem for one-to-one functions. So let's get started. We have two random variables, continuous random variables, x and y. These are not IID because even though they are independent, they are not identical. X has a gamma with shape parameter alpha, so that's a shape. And then the scale parameter is 1. And y has a gamma distribution with shape parameter beta, but the scale parameter is 1. So the scale parameters, these have to be the same. And then we can use the result that we're going to find for this section very easily as long as these scale parameters are the same. Then we will add the shape parameters and for one of these and get a gamma. But I'm getting ahead of myself. What we want to find is the PDF of u, which is x divided by x plus y. Now, in order to use the bivariate transformation theorem, we need u and v. And so if you recall from our last example, we had u was x over y, and we let v equals y, the denominator. We're going to do the same pattern now. We're going to let v equal x plus y, the denominator. Okay? And that pattern works. So it's the simplest we can do. V equals x plus y is certainly a one-to-one function. And u equals x divided by x plus y is a one-to-one function as well. All right. So looking back at example 2, that's how we determine what v should be in this case. Okay? Remember that the patterns are what we're looking at. They're very important for you to be successful in this section, the rest of this course. Okay. So I can write the joint PDF because they're independent. Then I know that f of x, y is equal to the marginal of x times the marginal of y because they are independent. And f of x is equal to, remember that this is 1 over, we'll call it theta, to the alpha, gamma of alpha, x to the alpha minus 1, e to the negative x over theta. I didn't want to use beta because we're using beta here. So I changed this to theta. So this is the form, and in this case, theta equals 1. So this simplifies to gamma alpha on the bottom, x to the alpha minus 1, e to the negative x, because negative x divided by 1 is just negative x. Okay? So I've gone a little bit further and put 1 to the alpha, 1 to the beta for that, and put the over 1 in both cases, but it simplifies to this expression. We have gamma alpha times gamma beta on the bottom. We have x alpha minus 1, y beta minus 1, and e to the negative x plus y. Because we have e to the negative x and over for the y, we'll have e to the negative y. We can add those exponents, right? Okay. So that is what I've done. And we have x is greater than 0, y is greater than 0, alpha and beta are greater than 0. We know theta, which is 1, so we don't have to put anything for that. Okay. We need to solve x and y in terms of u and v. So these are the inverse transformations. Okay. So we'll start with u this time, and we know that u equals x over x plus y, and we've defined x plus y as v, so we make that substitution. And then when we solve for x, we multiply both sides times v, and we get that x is equal to uv, and that is our h1 of u and v. Next, we're going to solve v for v equals x plus y. For y, we need an expression for y, and I can say if and only if here. Y is equal to v minus x. Now I will substitute in that x is equal to uv, and I have v minus uv equals h2 of uv. I can also write this as v times 1 minus u, which may come in handy. So now that I have those inverse transformations, I can calculate the Jacobian, which is the determinant. Remember, this is the determinant, which can be abbreviated det, the determinant of this matrix. So it's not the absolute value, it's the determinant. So I take the derivative of h1 with respect to u, and h1 is u times v. So the derivative with respect to u is going to leave me v, and that's what I have here. The derivative with respect to v leaves me u, and then I take, and again I can write this as v times 1 minus u equals h2 of u and v. And when I take the derivative with respect to u, then I get, remember the v is a constant, so I take the derivative of 1, that's 0, minus the derivative of u, which is going to be 1. So I have negative v is what I have left right here. And when I take the derivative of this with respect to v, the v becomes dv is 1, and I have 1 minus u. And remember that I take and multiply the diagonal here in this direction, so those elements, and subtract the product of the elements in the other diagonal. So I have v times 1 minus u minus a negative, so that's a plus, so please get your, make sure you get your plus and minus signs correctly. So I have v times 1 minus u minus negative v times u, which is positive uv. Now, there's a couple of ways you could do this. You could expand this, and it's simple to expand, or you could do what I did and what we normally do, and we factor. So I factored out a v out of both of these, and I end up with 1 minus u plus u. So those cancel, and I end up with just v. Now, the absolute value of the Jacobian is the absolute value of v, but that in this special case is just v, because remember that v equals x plus y. X is greater than 0, y is greater than 0, so x plus y has to be greater than 0. Okay, so v is always positive. That makes it nice and is going to simplify our PDF of u and v. So we're going to use the transformation theorem, and then the joint PDF of u and v is given by g of uv, gamma alpha, gamma beta in the denominator. And then in place of x, I have put u times v. So that's u times v to the alpha minus 1. And then, again, in place of negative x, I've put negative u times v. And now for y, remember, is v times 1 minus u. And that's raised to the beta minus 1. And then e to the negative v times 1 minus u. And don't forget to multiply by your Jacobian. Okay? And so we now look at the joint range of u and v, and this is a little more involved. So what I want is, so there's a couple of ways to do this. I could say 0 less than x less, not equal to, sorry. Okay, x is between 0 and infinity. Now that's uv, okay? And this one's very difficult, okay, to solve this way. So when we solve this, then we can see that we have u over v, and then we have infinity over v, and that's very difficult to see what the result is. So when you have something that's going to be like infinity over infinity, you don't exactly know what's going to happen. So I'm going to look for the minimum of u, and I'm going to look at the minimum with x and y. So this is the minimum of x plus y over, x over x plus y. Now remember, so these are always the same, okay? Always the same. So I can say, well, this is the minimum. This is going to be 1 over, so I'm going to multiply 1 over x and 1 over x, top and bottom, and I end up with 1 over 1 plus y over x. And so as x goes to infinity, it's a lot easier to see now that this goes to, that goes to 0, and this goes to 1. So as x goes to infinity, u goes to 1. And if y goes to infinity, then this quantity goes to infinity, and I have 1 over infinity, which is 0. And if I take the limit as x and y go to infinity, this is going to be 1 over 1 plus infinity over infinity. That's going to be a little difficult to explain, but this could be 1, so that would make the overall 1/2. It could be 0, which would make the overall 1. No matter what happens here, this quantity is going to be less than 1 and greater than 0, okay? So it turns out that u is between 0 and 1. And v was x plus y, and so x was between 0 and infinity, y is between 0 and infinity, so obviously x plus y is between 0 and infinity. So that one's easy. So it's really important that you be careful in evaluating this. Take your time and look, because here, if we had tried this method, we don't know really what we would get. We would have to take the limit as x and y go to 0, or as they go to infinity, and it's going to be a lot harder to see. So it's a lot easier because we already are dealing with infinity and 0, so that can make it more complicated. So this method of the limit sometimes is is better for finding out the range of u and v. Okay. So now that we know what a beta distribution is, we see that the range of u is between 0 and 1, and we're going to find, and this is part of your homework, I want you to find the marginals without, let me change this to red, I want you to find the marginals of this without evaluating the integral. So you can't evaluate the integral. You can set up the integral and look at this, And I'm going to give you the spoiler. I'm going to tell you what you're looking for. But you're still going to have to show it to me and prove that you know there's some tricks to this. So, okay. Now, actually, I think you don't have to do this for homework because I am going to do this in this video. So, yeah. So let's clean up a little bit. And let's take a look at this. So we find out that U is going to be a beta, alpha beta, and V is going to be a gamma, alpha plus beta, with 1 as the scale parameter. Yeah, scale parameter. Okay. So we have G of U and V. And what we want to do is, I'm going to let you do this, but you're going to have to rearrange this, and I want you to show how you expand actually this. Let me clear up again because it's just too much here. Go back to blue. So we have this. You'll notice that I have 2 e's. So you're going to try to combine those exponents. And then I have u and v raised to an exponent, and then I have v and 1 minus u raised to an exponent. So you're going to have to simplify this. And don't forget your v over here. Okay? And I'm breaking that apart, and when I put the u's, I have u's and 1 minus u's, I have v's, I have v, I have e here, I've combined the exponents, and then I use a trick. I multiply by gamma alpha plus beta over gamma alpha plus beta, and I separate them out in order to make u. So I put the u's together, so I take those, and I've got u alpha minus 1, 1 minus u, beta minus 1. Immediately when I see this, I know that I have a beta distribution, so I have to make the constants work, okay? And I already had gamma alpha, gamma beta in the denominator. I needed a gamma alpha plus beta in the numerator. So I multiply by that, and when I multiply by this, I also have to divide by this, and I put that over with the other portion. And then I have combined the v terms, and I end up with v of alpha plus beta minus 1. And then e to the negative v, and that would be over 1. And I see that I can make this into a gamma distribution. So you need to do that as part of your homework. Make this into the gamma distribution so it's very obvious that this is a gamma. Okay? So show the details. And I can see now that I can take this quantity and this quantity, and I can multiply them together, and I get a beta and a gamma distribution. So here's the result, that when x is a gamma with alpha and 1, and y is a gamma, beta 1, so they have the same scale parameter, then, and these are independent, then u equals x over x plus y. That is a beta with alpha plus beta. That's the distribution. But the addition of 2 gamma distributions with the same scale parameter, you add the shape parameters, okay? And yeah, so, okay, so x plus y, when x and y are gamma, as long as they have the same scale parameter, you can just add their shape parameters together. And the book does this generally. So instead of putting a 1 here, the book has theta, so that it's any value of the scale parameter, okay? So homework, we're going to assign 5.2-2 along with the homework up here where you're showing the details. You know the answer now, but you still have to work through the details and show me the algebra and the arrangement of this. So that will be it for this video. Don't forget to scan and upload your lecture notes before midnight, the date listed in the course calendar. If you have questions, come to virtual office hours. If you need an answer before you can make it to virtual office hours, email me. But I need two things from you. I need an email of the picture of the problem and a picture of your work so far so I can see how you're approaching the problem. That will help me help you quicker. Please be safe and take care of yourself. We hope to see you next time.